I'm Alex Brikoff, and I'll be hosting tonight's edition of the November 2020 virtual edition of the Eastside Get Together Clinic. As always, our clinic tonight is sponsored by the 4th Division of the Pacific Northwest region of the National Model Railroad Association. I'd like to introduce tonight's clinic titled Steam Locomotive Appliances, and it will be presented by Ted Becker. Ted will finally answer the age-old question, what is all that stuff hanging off of steam locomotives with all those pipes running all over, compressors, turbos, injectors, and so on. The clinic will also cover a bit on how a steam locomotive works and some history. Ted, it's all yours.
Hello. Saying this is an explanation of all of that stuff is kind of an overstatement. There's way too much to cover in one clinic. Also, there's a lot of variations in the various manufacturers and types of the appliances. So really just consider this an overview. Um, Here's an example, as we said, a Southern, I think it's a PS4 Pacific. And you can see a lot of the stuff we're going to talk about: air compressors, tanks, feed water heaters. I'm not going to talk a lot about bells, whistles, or lights because you all recognize those. This, by the way, is an Alesco feed water heater, the little barrel across the top. Here's another locomotive with lots of piping and stuff. This is a coffin feed water heater. I'll talk a little about that a little bit more. So how does a steam locomotive work? Well, when you heat water to a boil and expands into steam, it expands 1,700 times. If you combine this expansion in a vessel, it develops a lot of pressure. And that pressure can be used to turn a wheel. Now here's a diagram of a steam locomotive. Here's the fire in the firebox, boiling water, generating steam, which is routed down through valves with a piston and a crank on the wheel to turn the wheels. One of the things as you're boiling water and it keeps developing more and more pressure, if you don't bleed that pressure off, you got bad results, and you don't want that. So one of the first appliances we'll talk about is a safety valve. Here's a picture of a couple, one on a locomotive, a pair of them on a locomotive. Here's a diagram of how they work. There's a valve and a spring, and when the pressure is high enough, it pushes the valve open and lets the steam escape, and it reduces the pressure. There are always at least two on a locomotive, and are often set at slightly different pressures. So if the pressure just builds up slightly, one will release and keep the pressure down. But if it's really building up pressure fast, then the second one will open to reduce the pressure even faster. Here's some models. There's this, I believe this is a cluster of three, one larger one and two smaller ones. Here's a pair on this one. Here's four that are on top of a boiler in a rectangle, and here's four that are stretched across. So there's a variety of different ways they positioned them. They were almost always on the rear part of the boiler because that's where the most heat and the pressure was developing the fastest. The other thing that would happen is you're boiling this water and you're using the steam, the water level would keep going down. And eventually the water level would get low enough that this top part of the firebox called the crown sheet would not have any water on it. Now, even though that water was boiling, it was cooling the crown sheet. Well, when the crown sheet got dry, the temperature could go up into the red hot region. And when iron or steel gets red hot, it gets weak. And then you'll end up with something like this. So we needed a way to add water to the boiler. Pumps were the initial answer. I'm sorry I could not get a good picture of an old Civil War era locomotive that actually had a mechanical piston pump attached to the drive rods on the locomotive. This was a gear pump, which actually might be part of a feed water system. But most common was called an injector. What an injector did is it took a jet of steam through a venturi that drew in water, forced it into, increased the pressure enough that it would force it into the boiler. This is called an injector. And that was the most common way of delivering feed water through the majority of the steam era in the 20th century. Common types, there are a number of different brands, which I don't remember the names of all of them. Sellers was one I do remember. These things you see hanging down below the corner of the cab on either side of the locomotive were injectors. There were also injectors that were up on the side of the boiler. There's one here, and there's a slightly different version here. There were usually at least two because they wanted the redundance for reliability. And by the way, these model photographs are ones I took myself of my own collection. When you inject this water into the boiler, you want it to stay in the boiler. You want to keep the steam pressure in the boiler. So they had check valves, also known as clack valves. Usually there were two. Sometimes there were more. Here's some examples on the model. Usually up near the front, just behind the smoke box. They had this vertical style. There were horizontal style. There were some that were top mounted, usually fed from one from each side. But they had versions like this where they were fed from both sides. This one actually had 3 check valves. Probably this was from a feed water heating system. One thing you notice that these are always all located forward on the boiler, away from the fire, where the boiler was cooler, where the water in the boiler was cooler. Because as you know, if you boil water making pasta or something like that, and you add more water, it stops boiling. And you don't want to do that. They found that by preheating the feed water with a feed water heater, it improved the efficiency of the locomotive and reduced fuel consumption, which saved money. So they developed and installed feed water heaters. This is a different locomotive with the Alesco feed water heater, which is probably the most recognizable. I'm not going to go into all the detail about the piping and everything. One good resource for this information is Kalmbach's Locomotive Cyclopedia Volume 1. They have all piping diagrams and a better explanation and detail of the various feed water heating systems. On this system, it had a pump back here that pumped the water into the feed water heater and then on into the boiler. Is usually what you see on the sides, the air compressor, which I'll talk a little bit more, but in this locomotive, the air compressors were up front here. Here's another view of the coffin feed water heater. Part of this back here is also a pump associated with that. When they're stuck out on front like this you can pretty well be sure was a retrofit. Usually when they installed a coffin feed water heater at the time the locomotive was constructed, it went inside the firebox. Another common type was the Worthington, which this big shrouded unit on the side of the locomotive. I believe the feature of the Worthington feed water heater was it was driven by exhaust steam, but don't quote me on that. Like I said before, this is a little more detail than I wanted to get into in this clinic. On the models, if you see hatches like this and this and this on the top of the firebox, that's evidence of a feed water heater that's been installed at the time of locomotive construction and is inside the firebox. You've seen these on some locomotives. I believe this was another type of Worthington. Those of you who remember the old Mantua Mikados with that lump on front of the boiler in front of the smokestack, that was representative of a feed water heater. I went for years wondering what that was, and only after I got into this stuff did I understand. Another system that doesn't really fall in the area of appliance, but is also part of the locomotive system, is called a superheater. Another method for improving the efficiency of a locomotive and reducing fuel consumption is to superheat the steam. Wet steam is picked up in the dome at the top of the boiler, and then that steam is routed through pipes that are in the fire tubes of the boiler so that it increases the temperature of the steam considerably and quote unquote dries it out. And then that dry steam is used to drive the locomotive. This slide up here in the upper left shows superheater tubes being installed in a boiler. The lower left, you show them being uninstalled, not favorably, of course. Upper right is, this is a postcard of the superheater company in East Chicago, Indiana, where superheater tubes were made. And here's a builder's plate for the superheater company. This is special, and I include it because my grandfather, 2 uncles, and a cousin, basically all of my male relatives on my mother's side of the family in northern Indiana worked at superheater company in East Chicago. A couple of appliances that are generally only seen on superheated locomotives are, this is called a front end throttle. You see this external linkage. It's up on the side of the smoke box. It has external linkage. about halfway between the throttle lever and the cab, you'll see this bell crank arrangement. And the purpose of that is for temperature compensation of the actuation rods. As they expanded or contracted, the bell crank caused the expansion and contraction to counteract each other, so it didn't change the throttle setting as the temperature changed. Another appliance that's not easy to see is it's called a damper. It's a little counterbalance damper. Um, and the purpose of it was to control the flow of the hot gases through the fire tubes and to prevent overheating of the superheater tubes. Talk a little bit about the domes. A lot of people call these protuberances on top of the boiler domes, but they're not all domes. Some of them are sandboxes. So if you look here, if it has hatches on the top and tubes, pipes coming off the lower edge going down the side of the boiler, that's a sandbox. If it's plain like this, it has a whistle or some fittings on the side like this, then it's a steam dome. Rarely you will see an external throttle connection on the steam dome. Usually the throttle was in the steam dome and the linkage was actually inside the boiler. The purpose of the sandbox was to deliver sand down the sand pipes to deliver sand to the wheels for traction. And there's a number of different valving arrangements that was used for that. There's some examples here, more elaborate ones. These are pretty simple. The valving is contained inside the dome in these cases. So we've talked about making the locomotive go. So now we'll talk a little bit about making it stop. And that's the brake system. The locomotive, the railroad brakes worked on compressed air. So all locomotives have air compressors of various types. There's some examples that this is a pretty standard cross compound compressor that very nearly all modern steam locomotives had this style of compressor. There were some variations. There's a smaller one. This is on a little 080 switcher. Some of them had, some of them were more complicated. And like I said, I'm not going into the details of the differences. If you see these little rabbit ear things like that, and these little like rabbit ears sticking up here, those are pressure regulators. And then that compressed air had to be stored somewhere. So all locomotives had air tanks. Usually there were at least two, because the locomotive air brakes and the train air brakes were independent systems, and they generally had separate air reservoirs. Although the air compressors served both systems, usually where they split was at the air tanks. Also, when the air is compressed, it gets warm, and they like to cool it before they put it in the tank. So you will often see loops of pipe like this, and those are those are just simply for cooling the air. There's some more examples here of cooling pipes. I think this falls outside of the area of an appliance, but this is a view of a Walschaerts valve gear. Um, this this little arm that goes off here connected to a crank on the wheel, and it rocked this little rocker segment. Um, and then this radius bar was driven, had a pin that rode in the slot, and that bar rocked back and forth in synchronization with the rotation of the wheel, and it controlled the valves and the admission of steam into the cylinder. When this was dead center, like it's shown here, it didn't rock at all, and that was sort of a neutral position. And when they raised it, the it would emit steam such that the locomotive moved in one direction. If they lowered it, it went the other direction. And the mechanism, this lever arm, excuse me, I'm trying to point the finger with my screen. I pointed the screen with my finger, and you can't see that. um, this is called the reversing gear. And by control rod back to the cab, the engineer could adjust the position of the reverse gear and control forward and reverse, and also control the duration of the time that steam is being admitted to the cylinder. Now, this was heavy iron stuff, and it took a lot of effort to move it. So to make the job easier, they added these devices called power reverses. And this basically works on the same principle as your power steering in the car. You apply some pressure to the mechanism, and a valve opens, allowing some pressure to be applied to a piston to assist what you're doing. The typical positions varied. A lot of them were on the running board, above the running board. Some were hung low in a running board. This one being up front and pointed backwards was an unusual position for it. Um, but these are power reverse gears. A few other items. Um, on the bottom, we have turbo generators. The one over here on the bottom right, so kind of crude, but um, they were mounted just about anywhere on top of the locomotive. Um, some like this were up in front of the stack, some were in back of the stack, some of them were back by the cab. They could be placed anywhere. They're almost universally this round shape with an exhaust pipe sticking vertically. Um, and then there were conduits that ran to the lights. And the turbo generator, if you have a tsunami sound system and you turn the lights on or off, you can hear the sound of the turbo generator winding up as it built up speed. And they were little steam turbines and a little generator, not a whole lot different than a generator in your older cars. Also up here in the upper left is number boards, which were common on a lot of locomotive. Also, we can see here this little box with the square top. That's an electrical junction box. Handrails, of course. There were handrails running down the sides of locomotives. Let me back up here. Running boards, probably not considered appliances, but the locomotives had them. Here you can see example of steps up the side of the locomotive. Let me see if I can go back and point out a couple other things. Here on this lower right photo, you see this little round. Those were clean out plugs. They could open those up to get access to clean out the boiler. In this, you can see this right here is a lid for the smokestack. They could close to keep the rain out of the boiler. Also on the upper right, we see classification lights. I know some people call them marker lights, but when they're on the front of the locomotive, they're not marker lights. They're classification lights. And they were color-coded lights to tell you the class of the train. Again, I'm not going to get into details of how it works, but it could tell you if it was a scheduled train on the timetable, the second section of a multi-section train, or a non-scheduled extra. And that's pretty much the end. I said those lights on the locomotive are not marker lights. These are marker lights on the caboose. And I thought I'd give you a cast photograph of the locomotives that I used to take these photographs. So I'm open for questions. We can go back and look at more detail on some of these locomotives you want. I'll go back here, I believe, is a turbo generator. I said I wasn't going to talk about whistles, but here's a whistle. Now, there's something here I want to, maybe somebody can tell me what this is. You see this rectangular thing with this little arm going down?
That's a low water alarm.
Is that what that is? Okay. Thank you.
They made a very loud racket.
Yeah. In this photograph on the upper left, these round things with the pipe, those were blowdown mufflers. The blowdown was a valve and pipe fitting down at the lower part of the boiler, and the blowdown would open that up and allow steam pressure to blow sediments out of the boiler. And I guess it was very noisy, and they used blowdown mufflers to quiet it down. Another detail, like in the upper left photo, this little conglomeration here. This is a steam manifold where they broke off, where they could connect various pipes for steam fittings. This may have also been called a steam turret. This is more typically a steam turret. It's a fitting kind of like a dome that's been chopped off. But what it was a way to mount a steel plate in the boiler where that was flat, so they could drill and tap and add pipe fittings for things like whistles and safety valves. Yeah, let's see. I don't know if there's anything else I can point out on this locomotive just off the top of my head. Like I said, I'm open to questions.
Yeah, there's a question here from Fred Mertz. What was the effect of the USRA on locomotive design with different uses and fuels for railroads and manufacturers forced into just a few designs?
From what I gather, the USRA they came up with a series of standardized designs, so that for the war effort, well, basically the USRA they federalized the railroads and railroad manufacturing for the duration of the war, and the USRA were the standardized designs they used. There were quite a few of them built for the war effort, but they turned out they were very good designs. So there were probably more copies of USRA locomotive designs than there were actual USRA locomotives built. So they were quite successful. I don't know that they advanced the technology as much as collecting the better elements from various aspects of locomotive design to get to come up with good solid designs.
There's two radiator looking things right behind the smoke box. Are those part of the airline? They might just be more radiators for the compressed air.
That's probably what they are.
Yeah.
I think they were, Burr, those were unique to the GN's N3 locomotives.
Uh-huh. Those are the 288Os?
Yes.
Yeah, 288Os.
On the big boy, I have noticed, I don't know if it's on both sides, but on one side, there's two sprockets with a chained belt system between the sprockets. Do you or anyone know what the purpose of those?
My guess is that drove a lubricator.
Okay.
Something that pumped oil to various parts of the mechanism.
Yes, some kind of mechanical lubricator, probably.
Yeah,
Yeah,
I think that's right.
yeah.
I've always thought, seeing that out in the open, that it would be easy for that chain to slip off the sprockets, but if it works, it works.
It worked. Yeah.
Thank you.
Usually stuff that the railroads did was, from an engineering perspective, what we would call big by wide. So it was really heavy duty and wouldn't be easily taken off the sprockets outside.
Well, there's when we talk about lubricators, in some cases, and I could not find a good photograph of it, but on the valve gear or on the crosshead guides, which are the two bars that come out behind the cylinders that the crosshead slides on. Often you'll see above that a box with a little arm that's connected to that mechanism that rocks the little arm back and forth. Well, that's a mechanical lubricator that's generally pumping grease or oil to the crossheads. But
Ted, do you have anything to talk about the backhead?
the backhead? No. The backhead, the one thing I noticed about locomotive backheads is there's lots of valves and none of them are labeled. So that must have been an important part of the fireman's training, was to learn the purpose of each of those valves.
You know, one thing on the backhead to that question that you might see in some of the more detailed brass locomotives, certainly in actual locomotives, was a cold stoker. and there would be two, a screw coming from the tender, and then usually kind of a V-shaped distribution device into the firebox.
And yeah, that was an area that I didn't get into. The other thing you see on coal tenders is on the back, the slope sheet at the back of you'd see a coal pusher, a piston that would push the coal down to the stoker.
On locomotives operated by the narrow gauge in the mountains where there was a lot of ice, they would have ice breakers that were teeth that were mounted underneath the pilot, and they would drop down and break ice in the flanges.
Yeah.
And those had a rod gearing or a rod mechanism back to the cab that is quite pronounced on a lot of the smaller narrow gauge locomotives.
Yeah.
Ted said about the injector, and something that I've always thought was just ingenious. And if you think about an injector, you're taking something at pressure out of the boiler and actually forcing water back into the same boiler at that pressure. And so the engineering behind the injector with the Venturi is really quite an ingenious device.
It was, yes, amazing piece of engineering. It just by the velocity and the shape of the Venturi, we're increasing the pressure enough to force it into the boiler.
The plumbing on an oil-fired locomotive is going to be different because of the oil coming from the oil tank and the tender. There's some additional piping.
Yeah. Well, one thing was steam lines, because the oil bunker C, it was almost as thick as paving tar, and they had to heat it up to get it to flow.
Okay, but that's about it. We'll see everybody later. Bye-bye.